Alrighty, so a square number, and as you can see, there's a whole bunch of information here that we have that we're going to have a look at. So a square number can essentially actually be drawn in a square. So a square array just means draw a square of the value that you're working with. So for example, 25 is shown as 5 blocks by 5 blocks. That is 25. If we said 5 times 5, we would get 25. Now, what you need to notice here is that we are multiplying the same number 5 twice. And so what that actually means is that we can write this as 5 squared. We can call it to the power of 2 or 5 to the power of 2. Oh, golly. Sorry, everyone. 5 to the power 2. And you could also call it or say it 5 squared. I say 5 squared, but if you say 5 to the power 2, that's absolutely fine. So when we've got the same number being multiplied twice, we are working with a square number. The inverse, or the opposite, is when we find the square root of a value. All right, so finding the square root is the inverse of squaring. Now, what this is actually asking me is it's saying, if I want the square root of a number, what two numbers do I multiply together in order to get that value? So for example, if we wanted the square root of 25, I'm essentially asking what two identical numbers do I multiply together in order to get 25? And if we go back to our square, we know that we multiplied a 5 and a 5. And so the square root of 25 is 5. Okay, so square roots and squares work hand in hand. They are basically the inverse operations of each other. And that's how we can go from one to the other. We're going to do a few examples as we go along. But really importantly, a square is when you multiply two of the same values. A square root is asking you what single or what identical values are you multiplying in order to get an answer. It all sounds very confusing. I know it's a lot of words, but it's really important that we do understand the difference. So what I'm going to do just for a second, because I don't want you to miss out on any screenshots, is make my screen like that. And if you want to take a screenshot at this point, please do. I don't know why this thing doesn't want to go away. No. There. Okay, it doesn't get any better. Sorry. Okay, so if you want to take a screenshot of that information, do that. And then we'll have a look at another example. So again, squaring is multiplying a value twice. So here we saw we had 5 times 5 because we have 1, 2, 3, 4, 5 squares by 5 squares. 5 times 5 or 5 squared. Whereas the square root is looking back at what was the original value that I multiplied twice. And in this case, it was 5. So if we have a look at another example here, we can have a look at any square we really want, as long as the square is a square, so it's got the same length size. So here we've got a square that's 7 by 7. If you count your blocks, you can see that. So 1, 2, 3, 4, 5, 6, 7, 1, 2, blah, blah, blah. So we've got a 7 by 7 block. If we multiply the 7 by 7, we get 49. If we now go the other way and we do the inverse, and we took the square root, the square root of 49, we would get 7. It's taking me back to the original number that I multiplied the side by the side. Now, guys, you don't have to think of it as a square. I personally just think of it as what two identical numbers I am multiplying to get the answer that I want, or to get the root, or whatever it is that the question is giving me. But a square is a really nice visual representation of what's going on. Okay, now you can square any value, anything you want. You could square a fraction, a decimal. As you've seen here, we can square whole numbers. You can also square, and this is really important, you can square negative numbers. But please, please remember that when we have a negative times a negative, we get a specific sign. So who can tell me what sign we get when we say a negative times a negative? Nice, Azande. Very good. Uma, nice. Tando, awesome. Itandile, nice, guys. Well done. All right, so that's really, really important. When we have a negative times a negative, we actually end up with a positive answer. And so, yes, you can square a negative. That's absolutely fine. But just remember that when you square a negative value, you do end up with a positive answer. So that's really, really important when you do square a number. And we'll have a look at a few examples like this in a second. What is also really important to remember is that when we square root a number, so if we look at the 49 again, when we square root a number, we're going back to the two identical values that we multiplied together in order to get 49. And when I say identical, I mean identical, grade 8s. So I'm actually going to write a little note here. So when square rooting, we want the two identical, that's what I can spell, identical values that we multiplied to get, in this case, the 49. Now, when I say identical, they have to be identical in sign and they have to be identical in value. So you can't, for example, say, okay, well, the square root of 49 is -7 and +7. That's not identical. Firstly, it doesn't work, but they're not identical. They have two different signs. So they have to be identical in every single way. Now, because of this, we cannot, and this is so, so important, often people forget this, we cannot calculate the square root of a negative number. And the reason for that is because in order for us to get a negative value when multiplying two numbers, I would have to multiply a positive and a negative. And those values are then not identical. So that's what this is saying down here. This is a really bad highlighting job that I've done here. Let's attend to that situation again. So -9, hello. Goodness gracious. -9 is found by saying +3 times -3. Those are not identical values, and so we cannot find the square root of a negative. Now, even if you go type on your calculator, my calculator is a bit old and gross, so just excuse that. So even if you go type the square root of -9 on your calculator, if you push answer, it gives you math error. And that's because we cannot actually find two identical numbers that we multiply together in order to get a -9. So really, really importantly here, we cannot calculate the square root of a negative number. You can only work out the square root of positive numbers. Okay, so again, I'm just going to wait here for you guys to screenshot those notes, and then I'll scroll down to the next little bit. And guys, remember, if you have questions, I know this is a lot of information to start off with, and it will become a little clearer as we do the examples. But if you do have questions, feel free to raise your hand. Feel free to use the chat. I've got the chat open. I can see when you raise your hand, so you just need to ask. Okay, last call for screenshots, otherwise I'm going to move. Cool. All right, so there's a bunch of extra information down here, which I'll let you take a screenshot of if you want. But we'll have a look at these sorts of situations as we start to go through our examples. So I'll leave it here if you do want to take a screenshot, you're more than welcome to. And it's just the basics of how we actually work with square roots and with squares. Now, there's lots of different sort of ways we can deal with it, especially when we start talking about exponents. And as you do more exponents, you'll see that how you choose to work it out, as long as you follow the rules, there are often a few ways to do it. But we'll look at these examples as we actually do some examples. So again, I'm just waiting here in case you want to square root this extra information over here. It just gives us a general idea of what happens. So for example, the square root of 9 times the square root of 9, the square root of 9 is 3, so you're actually working with 3 times 3. If you have the square root of 9 squared times the square root of 9 squared, you're working with the square root of 81 times the square root of 81. Square root of 81 is 9, and so you're actually working with 9 times 9. All of these things we will chat about as we go through some examples. All right, so for those of you that have joined a little late, just a reminder, Teacher Kirsty is still around, I promise. She's unfortunately stuck in traffic and couldn't join the lesson. If she's able to, she will definitely jump on. But tonight, I'm just filling in for her. She will be back on Monday, on Tuesday. So don't stress, you don't have me forever. Teacher Kirsty just wasn't able to make it. Alrighty. Okay, guys, so let's have a look at some examples here. Oopsie. So the first example is asking us to write each of the following in a shorter way and then calculate the answer. So let's just take a second and actually figure out what does that mean. So when we say in a shorter way, another way we can ask you this is to write this answer or to write the expression in what we call exponential form. And basically what that means is if you are multiplying the same number twice or 3 times or whatever the case is, you can actually write it as an exponent. So I'm going to do the first example with you and then we'll try a few by ourselves. So if we look at 3.1.1, I've got 9 times 9. Now that's exactly the same number. They're identical in every way. They're both 9. And so what we are doing is we are actually multiplying the same number twice. And because of that fact, we can actually write this in a much simpler form of 9 squared. So when it says in a shorter way, we are asking you to write it with an exponent. We then obviously want to calculate the answer to that expression. And so in this case, we now want to work out what is 9 times 9. And 9 times 9 is 81. So this is a real good test of your times tables. So remember, and I said this right at the start, when we are multiplying the same number twice, we can write it with an exponent of 2. So let's have a look at 3.1.2 together. This is saying 12 times 12. Again, they are identical, same number, same sign. And so I can write this in an exponential form of 12 to the power. Calculate what our answer is. 12 squared or 12 times 12 is 144. So if we want to write something in a simplified or a simpler manner, we can write it with an exponent. Nicely, Sandile, I see your answer there. Awesome. Right, if we have a look at 3.1.3, this is a little different because we've got negative signs. Now, what I want you to notice is that these negative signs are inside the bracket. Now, there's lots of different ways we can think of this, but because they're inside the bracket, they're part of what is going to be attached to my exponent. We already know, and you told me earlier, that a negative times a negative is a positive. So already in my mind, I should be thinking, okay, when I calculate the answer, that should be a positive. But let's first write it in that shorter, simpler way. So we've got negative 5 times negative 5. And so in a shorter way, this is actually saying that I want to take negative 5 and square it. I want to multiply it twice. When we calculate our answer, we know that we've got a negative times a negative, and we know that's a positive. And we know that 5 times 5 is 25. So even when there is that negative, nice guys, I love that we've got these answers coming in the chat. That's awesome. So even when we have these negatives that we're multiplying with, we don't need to stress. We put it in our bracket, we raise it to the power of 2, and we've written it in the simplified form. So I'm going to give you guys, let's say 3 minutes, a minute per question. And I want you guys to try for me, oopsie daisies, I'm just drawing lines everywhere. I want you to try 3.1.4, 3.1.5, and 3.1.6 for me. So you're going to write it in the shortened version, and then you're going to find the answer for me. And then we'll see what we get. You are more than welcome to put your answers in the chat if you would like to share that with us. And you are also more than welcome to, if you have questions, put them in the chat or raise your hand. But let's try 3.1.4, 3.1.5, and 3.1.6. Hopefully, we are going to get to cubes today. I'm fairly certain, hopefully, as long as we work efficiently. But we are going to look at cubes as well. If you don't look at cubes today, we will be looking. You will be looking at them on Tuesday with Teacher Kirsty, but you are going to do cubes. Okay, so guys, write it in the simpler way or the shorter way, and then find the answer for me. Was on it. Nice, guys. Okay, so Nkuli, I did say that they could put the answers in the chat. It's also a way for you to check if you're getting it right. It's a way for us to see if we agree with each other. It's a way for us to check each other and essentially work with each other. If it's going to upset you or annoy you, just minimize the chat and then you can open it again once we do the answers. Okay, so guys, putting answers in the chat is a really good way to just double check. It's okay if you don't enjoy it, you just minimize the chat. So you can open the chat again when we're done. It's just nice for you to be able to see, oh, okay, everyone's getting this answer. I haven't gotten that answer. Maybe I've gone wrong. Or, okay, cool, everyone's getting the same answer as me. I'm on the right track. Okay, I'm going to give you one more minute and then we'll have a look. Make sure you are doing it grade 8. That's the way we learn. And remember, when we go through the answers, make sure you are marking yourself so that you know whether or not you've gotten it right or wrong. Okay, let's have a see. So I'm just going to shift that up a bit so that we've got some space here. So 3.1.4. Oh, God, this money. Okay, try that again. 3.1.4 was negative 20 times negative 20. Sorry, who knows why there's a line all of a sudden there? You know, technology. Okay, identical numbers being multiplied. Don't have to stress about, are they different? Are they not? They're identical. And so what we have here is negative 20 squared. Now remember, negative times a negative is a positive. 20 times 20 is a positive 400. Now grade 8, some schools and some teachers do and don't allow you to use calculators when you are doing tests and exams and stuff. So always just make sure you can do a multiplication of big numbers, not necessarily in your head, but that you can work it out without a calculator. There's lots of different ways that you can do this. You've been taught a lot in primary school how to do this, but always just make sure that if you're not allowed to use a calculator, you do have methods to deal with it. Okay, so for example, I know my grade 8 aren't allowed to use a calculator yet. All right, if we now have a look at the next one, we've got 3.1.5. This is 16 times 16. They're identical values that I'm multiplying. So this is going to be 16 squared. If you want to write this with brackets. So if you wanted to say bracket 16 squared, there's nothing wrong with that. Okay, it means the same thing. If the brackets help you remember that you are squaring the positive 16, that's absolutely fine. Whoopsie daisies. Right, and then obviously we actually have to go and square that amount. So we've got 16 times 16, and that gives us 256. Right, and then the last one, we've got 6, we've got 400 times 400. That gives us, in a simpler way, 400 squared. Again, if you want to write it in brackets, you can. If you left it out, that's fine. But we end up with 400 times 400, which is going to be quite a big number. So just make sure you do get all your zeros in. It gives us 160,000. Makes sense? We're timesing 400 twice. It should be quite a big number. And so we get our answer. So just really importantly, grade 8, if you've got a negative, so like we had in 3.1.4 and then the 3.1.3, if you've got a negative, you will need to add these brackets in around the number that you're multiplying twice. Because if we don't, that will change things. I'll explain that now in a second. If we don't put brackets around the value that's negative, we will have a problem. Okay. So, Zandi, in answering your question, hopefully we were listening. Oh gosh, sorry guys. You do not have to put brackets if the value you are squaring is positive. If the value you are squaring is negative, you must put the brackets around. And I'm going to explain this now quickly. So guys, I'm going to say it again. If the value you are squaring is negative, so do this again. So like 3.1.3 and 3.1.4, then you must put brackets. But as you can see, for 3.1.1, 3.1.2, 3.1.5, etc., I didn't put the brackets in. That's not necessary. I said you can if you want to, but you don't have to. Not when both numbers are positive. Right, so I'm just going to leave this there for you to screenshot, and then I'll explain why we should have the brackets if it's negative. There's a few people with hands up and hands down. So while we're taking screenshots, if you do actually have a question, you can raise your hand and we can deal with it. Otherwise, I'll quickly explain why we have to have the brackets. Okay, so guys, the reason why we have to have the brackets is if we look at 3.1.3, if we have -5 and we're squaring it, what that means is we've got -5 times -5, negative times a negative is a positive, 25. So because we're squaring the whole negative value, we end up with a positive. If, however, we had -5 squared, so we didn't have any brackets, what this is actually saying to us is we've got minus and then we've got 5 squared. So this negative is actually acting as a coefficient. So you can think of it as that imaginary -1 that we have in front of the bracket. And so what that means we're dealing with here is a situation where we've got, oh gosh, yes, I want to see if it does it. Okay, whatever. We've got -1 times the 5 squared, so times 5 times 5. -1 times +5 is -5, and -5 times 5 is -25. So if our bracket does not include the negative, we will have a negative answer. So have a look here. Our bracket had the negative sign in it, but our answer ended up being positive. Here, the negative sign was not in a bracket, and so I have to treat it as a coefficient. And so that means my answer ends up being negative because I would say 5 times 5 times that -1 coefficient. So the brackets are really, really important. This is why we always say to you, brackets are important in maths and when you substitute and when you are solving for unknowns. It's really important that we remember the brackets. Okay, so that's why we have to have the brackets there. If we don't, it does change things. So just be mindful of that. I'll leave it there in case you do want to take a screenshot of that little note I've got there in pink and then couldn't change back to pink. Right, and then we are about halfway, so I'm hoping we've got a brain break somewhere, hopefully. Oh, no. All right, well, we're going to take a break anyways, because our brains have been doing really well. So there we go. If you need to take a screenshot. Right, and if you need a little break, let's get up, let's stretch, let's move before we carry on for the next sort of 25 minutes. If you need to run to the bathroom, run to the bathroom. We've got a little break now, and then we're going to carry on looking at our square roots. Right, guys, please also just remember that we're not talking nonsense in the chat. We are not making weird captions and whatever else I can see is going on. Please remember the chat is for maths. I will just disable the chat if we're not going to talk about maths. But you've got 2 minutes and then we're going to carry on. Okay, grade 8. Let us carry on. Again, make sure you've got your screenshots here, but we're going to have a look at some square roots now. So remember, that is the inverse of squaring. And we just need to be mindful of what that entails now. Alrighty. Okay, so let's have a look at 3.2 here. I'm going to make that a bit bigger so we can actually see what's going on. Here we now have the square root, and we have to understand how to deal with that. Now, I think of it one way, there's another, there's like lots of ways you can think about this. Obviously, when you start being able to use your calculator, you could just use a calculator, but we actually need to understand what the calculator is doing. So we have got 3.2.1 here, and I'm going to explain it in 2 different ways, and you can decide which one works best for you. So the first way we can sort of do this is using Teacher Kirsty's really awesome diagram that she put up there with the square. So remember, the square must be a square, firstly, and in this case, it should contain 4 blocks. So if I draw my square, hopefully I can draw a relatively big square here. Okay, it's not the best looking square, but we're going to work with it. There's my square, and it's got the 4 blocks. I know it's a square because the sides are equal in length. And so if I now want to work out the square root of 4, what I want to go and have a look at is the side length. If I go and have a look at my side length, and you can go whichever side you want, it doesn't really matter. The side length is 2 blocks. And what that tells me is that the square root of 4 is equal to 2, because that is the side length of our square. Now, you don't have to think of it like that. The way I think of it is, what 2 identical numbers do I have to multiply together to get 4? They have to be the same sign, same value. They have to be identical. And I know that in order for me to get 4, 2 identical numbers, I would multiply as 2 times 2, which therefore means the square root of 4 is equal to 2, because that's the identical number that I'm multiplying. However you choose to think of it is completely up to you guys. The squares is really nice English because you can imagine the side length. If you would prefer to think of it as what 2 identical numbers am I multiplying together, that's also absolutely fine. Both ways are going to get you the answer. If we have a look at 3.2.2, I'm going to be honest, I'm not going to draw. Actually, if I make it small, I'll be able to fit it in. Otherwise, we're never going to fit it in. Oh, okay. Bear with me. It's going to be an interesting looking square. And remember, because I've got 64 underneath my square root, I have to have 64 blocks. That's why I said it's going to be a very interesting looking situation here. Right, so here's my square. If you actually wanted to count all the squares, there would be 64. You can take my word for it. I have just double checked. So what we now want to have a look at is the side length again. Okay, so my side length, the square root of 64 is equal to the side length, 1, 2, 3, 4, 5, 6, 7, 8 blocks. So that is 8. Alternatively, the 2 identical values that I times together to get 64 is 8. 8 times 8 is 64. And so the square root of 64 is 8. Itandile, question?
Ma'am, I have a question about how you did 1.1.1 and how you did your square. And I also want to ask, ma'am, can you please do 3.2.4?
Okay, so I am just trying to work through the examples. So just give me a second. I will get to all of them. So I will get to 3.2.4. So don't stress.
Yes, ma'am.
Let's go back to the first question that you asked me. You said, how did I do the square? So, like,
Yes,
are
ma'am.
you asking how did I decide that that's what the square should look like?
Yes, ma'am.
Okay, cool. So, guys, in terms of why did I draw the square the way I drew the square has to have, skip over that. The square has to essentially have an area of 4. So, when I say an area of 4, it should be made up of 4 blocks. Now, because it's a square, each side has to be the same length. So I can't say, for example, draw a rectangle that has got 4 blocks. Yes, that's 4, but it's not square, because remember, we're working with square numbers. So what I would actually need to do is I would actually need to draw a square that is 2 blocks by 2 blocks. Because what I then see is that each side length of my square is identical. They're all 2 units long. And so that is why I am saying I'm working with a square number. The side lengths have to be identical. So that's why I've drawn my square with 2 and 2. And I see that my side length is 2 blocks or 2 units, giving me the square root of 4. If we have a look at this one as a sort of second example, oopsie. Each of my side lengths here are 8. That's 8 blocks. That's 8 blocks. This is 8 blocks. This is 8 blocks. again, I'm creating a square. It's a perfect square number, 64. And because I've got this square shape now, where the side lengths are all 8 blocks, I know that the square root of 64 is 8. Now, you don't have to draw the squares. Obviously, if the squares get very long, so like Itandile said, what happens now in 3.2.4 where I've got a million? That's really, really big. And I don't want to have to draw out a million squares. That's quite tough. But it's a really cool way to visualize what's going on. All right, so if we have a look at, seen as it's been mentioned, if we go and have a look at 3.2.4, we've got negative square root a million. That is a really big number. Okay, so for us to try and go draw a square with a million blocks, that's just, it's not going to happen. So we now need to ask ourselves, what two identical numbers do I multiply together to get a million? Now, guys, think of it a slightly different way. A million has 6 zeros. Now, there's lots of ways we can multiply a million, but remember, they have to be identical. So if we think back to like a more basic example, 10 times 10 is 100. 100 times 100 is 10,000. Each time you can match up the number of zeros in what you're multiplying to your product. So 10 times 10, there's 2 zeros. That gave me 100. 100 times 100, that's 4 zeros. So my answer had 4 zeros. So now I need to ask myself, okay, well, I've got a million. That's 6 zeros. I have to multiply by the same number twice. So if I divide the 6 zeros directly in half, so by 2, exactly as Zandi said there, we get 1,000. Got 1,000. So have a look here. 1,000 times 1,000. In total, I've got 3 zeros times 3 zeros. And that's going to give me an answer that combines the 3 zeros into 6. So I get a million. And so here, we now know that the square root of a million is 1,000, because those are the two identical numbers that I'm multiplying together. Right now, there's a negative sign in front there, and I think this is probably where Itandile was needing, or where all of us actually are needing a bit of explanation. Excuse me. Okay. What I explained earlier, so over here, when that negative is just sitting there, it's not in a bracket, it's not underneath the square root, which we know it can't be. If it's just sitting there like this -1 is sitting there, what we need to remember is that there's actually that invisible -1 in front of my square root. And so what this is actually saying, and I don't know why I chose yellow, is -1, I don't know why I'm choosing lime green, I'm really not doing well here, is -1 times the square root of a million. So now we worked out, sorry guys, this is all over the place. We've just worked out that the square root of a million is 1,000, and we still want to times that by that -1 coefficient. And so what we end up with is -1,000. So Itandile and everyone else, really good question. When that negative is outside my square root, what we need to remember is that it's actually telling me to say -1 times whatever the square root is. So in this case, I have to say -1 times the square root of a million, which was -1 times the square root of 1,000, or times 1,000 rather. Okay, so whenever we've got this negative sign in front of our square root, there's a few examples here. So let's please remember to be on mute. I really don't want to have to search through all of you to mute you. And if you're not going to mute yourself, I'm just going to remove you and put you in the waiting room. Every time there is that negative in front of your square root, you need to remember that it's saying -1 times the square root. It's a coefficient. So if we remember that, we should be okay going forward. So with that being said, what I want you guys to try is the bottom row. So 3.2.5, 0.6, 0.7, and 0.8. Try those four for me and see what you get, because they've all got the negatives, and I've just explained what the negative means. So let's give those four a try and let's see what we come up with. Remember, if you've got questions, you're more than welcome to ask. And again, just remember when we've got that -1 in front of our bracket, so this in front of our bracket, in front of the square root, it is a coefficient. So exactly like I've explained here. So just remember that. Sorry guys, I'm going to move that up. And I'll make it a bit bigger so you can actually see. Sorry. Okay, grade 8, so I'm going to give you another 2 minutes and then we'll go through them. I don't see any answers on the chat, so I don't know if we're actually doing it. I hope we are. Okay, so guys, remember, think very carefully about what your sign should be. All right, guys, let's have a look. So I'm gonna move down to, gosh, where we've got some space here. So I'm running out of space. Okay, we're just gonna ignore the circle. Okay, so those were the 4 questions that I asked you to do. There we go. It's sorted it like that. Let's have a look at the first one. Now, again, please remember that in front of all of these, we've got a -1 in front of my square root. So in each case, it's actually saying -1 times the square root value. So in the first example, 3.2.5, what we are actually working with is -1 times the square root of 1. So we're first going to work out the square root. So we'll leave the -1 there. Now, if that's confusing you, remember this -1. Sort this out. Gosh, guys, sorry. Silly thing. Okay, so the whole thing is just gone. So let's start again. -1 coefficient times the square root of 1. That's what it's saying. So, okay, I don't know what you're doing, but let's stop that. So let's leave the -1 there, and we're now going to find the square root of 1. So the square root of 1 is what identical number, two numbers, do I multiply together to get 1? Well, that's 1. If you want the square, there's your square. It's a 1 by 1 square, because all of the sides are the same length. And so the square root of 1 is 1. We then need to consider what -1 times 1 is. A negative times a positive is a negative. 1 times 1 is 1. So we get a -1 for the first question. If we go and have a look at 3.2.6, again, please bear in mind that what you're dealing with is -1, because there's the -1, times the square root of 16. So again, we'll leave the -1 there. We'll deal with that in a second. But now we want to know what the square root of 16 is. So if you need your square, oh golly, sorry. This is not the prettiest square in the world, but we're just going to roll with it. Oh my gosh. Oh no, it's just gone from bad to worse. Right. Let's try that again. Okay, terrible looking. Oh my gosh, it's actually just really bad. Let's just get rid of that and try and try that again. That was embarrassing. Right. Sorry, guys. Okay, my square was also looking incredibly dodgy. Right, there are 16 blocks there. If you count the blocks, there's 16. If you look at the side length, it's 4 by 4 by 4 by 4. So the square root of 16 is 4. So we've got -1 times 4. Negative times a positive is a negative. 1 times 4, -4. So because of that -1 in front of my square root, I am going to have a negative answer because I'm multiplying by a -1. Right, if we have a look at 3.2.7, okay, right, there we go. 3.2.7 is now saying -1 times the square root of 10,000. Now, I actually did this earlier on, so we'll have a look again. So -1 times. Now, remember, 10,000 is coming from 100 times 100. Those are the two identical numbers that we multiply together in order to get 10,000. I know that because 10,000 has got 4 zeros. If I divide 4 by 2, I get 2. So I need the two factors of 10 that have 2 zeros, which is 100. 100 times 100, or 100 squared, is equal to 10,000. So the square root of 10,000 is 100. And -1 times 100 is -100. So hopefully what you're seeing here is that every single time we have this negative in front of our brackets, our answer is always going to end up being a negative. So whenever we've got a negative in front of that square root, our answer is going to be a negative. Right, if we have a look at the last one, we've got 3.2.8, which is -1 times the square root of 144, or negative square root of 144. So again, we've got the -1 times the square root of 144 is 12, and so we get negative 12 as our answer. So really importantly, grade 8, when there is that negative sign in front of your square root, your answer is going to be negative, because that negative in front of your square root is a coefficient of -1. And we have to then remember to multiply by that -1 in order to get our complete simplified answer. So that is really, really important. Again, anytime you see that negative in front of your square root, you are going to have to say -1 times the answer of your square root. All right, so I'm just going to stop there for you to hopefully finish marking and for you to take a screenshot if you need to take a screenshot.